Hey there, science fans! Today, we're diving into the fascinating world of machines. What is a machine, you ask? Well, it's anything that makes work easier. That's right, machines are our little helpers, making tasks simpler and faster. Imagine trying to lift a heavy rock without any help. Tough, right? Now picture using a long, sturdy board as a lever. Suddenly, lifting that rock becomes a whole lot easier. That's the magic of machines. Machines work by changing the direction of force, increasing the magnitude of force, or changing the distance over which a force acts. Think about using a ramp to push a heavy box into a truck. You're pushing the box over a longer distance but with less force. From the simplest tools to complex gadgets, machines are everywhere, making our lives easier and more efficient. So buckle up as we explore the amazing world of machines and discover how these ingenious inventions shape our world. Now that we know what machines do, let's meet the basic building blocks of mechanics, simple machines. These ingenious devices are the heart of more complex machines and are incredibly useful on their own. There are 6 types of simple machines: levers, pulleys, wheels and axles, inclined planes, screws and wedges. Each of these machines works in a unique way to make work easier. Levers help us lift heavy objects with less effort. Pulleys let us lift things straight up using ropes and wheels. Wheels and axles help us move things quickly and efficiently. Inclined planes make it easier to move objects up or down a height. Screws are like inclined planes wrapped around a cylinder, and they help us fasten things together. And wedges? They're great for splitting things apart. In the following sections, we'll take a closer look at each of these simple machines, exploring how they work and where we can find them in action. Get ready for some serious mechanical fun. Let's start with levers, one of the most common and versatile simple machines. A lever is a rigid bar that pivots around a fixed point called a fulcrum. To use a lever, you apply a force, called the effort, to one part of the bar to move a load at another part of the bar. Think of a seesaw. The board is the lever, and the central support is the fulcrum. When you push down on your end, effort, the other end goes up, lifting your friend, load. Levers make work easier by changing the direction of force and the amount of force needed to move an object. There are 3 types of levers, classified by the position of the fulcrum, load, and effort. In a first-class lever, the fulcrum is between the load and the effort, like a seesaw or a crowbar. In a second-class lever, the load is between the fulcrum and the effort, like a wheelbarrow. And in a third-class lever, the effort is between the fulcrum and the load, like your arm bending at the elbow. Levers are everywhere. We use them to open bottles, pry things open, and even play sports. Understanding how levers work helps us appreciate the power of these simple machines in our everyday lives. Next up are pulleys, another ingenious simple machine that makes lifting heavy objects a breeze. A pulley is a wheel with a groove around its edge, designed to accommodate a rope or cable. By attaching a load to one end of the rope and pulling on the other end, you can lift the load with less effort. The pulley redirects the force you apply, making it easier to lift objects vertically. There are 2 main types of pulleys, fixed and movable. A fixed pulley is attached to a stationary object, like a ceiling beam. It changes the direction of force but doesn't decrease the amount of force needed to lift the load. A movable pulley, on the other hand, is attached to the load itself. As you pull on the rope, the pulley moves along with the load, reducing the amount of force required to lift it. Pulleys are often used in combination to create pulley systems, which can significantly reduce the effort needed to lift heavy objects. From construction cranes to elevators, pulleys are essential for lifting and moving heavy loads in various applications. Section 5. The wheel and axle. Rolling into action. Let's roll into the world of wheels and axles, a simple machine that's all about smooth and efficient movement. A wheel and axle system consists of a wheel, a larger circular object connected to an axle, a smaller rod that passes through the center of the wheel. When you apply a force to the wheel, it rotates, causing the axle to rotate as well. This rotation allows you to move objects over a distance with minimal friction, making it much easier than dragging or carrying them. Think of a car. The tires are the wheels, and the axles connect the tires to the car's frame. When you turn the steering wheel, you're actually rotating the axles, which in turn rotates the wheels, allowing the car to move in different directions. From cars and bicycles to skateboards and shopping carts, the wheel and axle is a fundamental simple machine that makes transportation and movement a whole lot easier. Section 6. Inclined planes, taking the slopes easier. Now let's talk about inclined planes, simple machines that make it easier to move objects up or down a height. An inclined plane is simply a flat surface that's tilted at an angle, forming a slope. Instead of lifting an object straight up, you can push or pull it up the inclined plane, requiring less force but over a longer distance. The steeper the angle of the inclined plane, the more force you need to apply, but the shorter the distance you have to move the object. Think of a ramp leading up to a loading dock. Instead of lifting heavy boxes vertically into the truck, you can use the ramp to push them up gradually, requiring less effort. From ramps and slides to staircases and even roads winding up mountains, inclined planes are everywhere, making it easier to navigate changes in height. Section 7. Screws, twisting our way to efficiency. Let's dive into the world of screws, fascinating simple machines that combine the principles of inclined planes and rotation. A screw is essentially an inclined plane wrapped around a cylinder, forming a spiral ridge called a thread. When you rotate a screw, the threads bite into a material, like wood or metal, and pull the screw into the material. The closer together the threads are, the more force the screw can exert. Screws are used for various purposes, from fastening objects together to lifting heavy objects. Think of a jar lid. The spiral ridges on the inside of the lid are screws. When you twist the lid, the screws engage with the threads on the jar, creating a tight seal. From light bulbs and drills to bottle caps and even DNA's double helix structure, screws are essential for countless applications, showcasing the power of this simple yet ingenious machine. Section 8. Wedges, splitting the difference. Last but not least, let's explore wedges, simple machines that excel at separating objects. A wedge is a triangular-shaped tool that's thick at one end and tapers to a thin edge at the other. When you apply a force to the thick end of a wedge, it exerts a force outward, splitting or separating the object it's driven into. The longer and thinner the wedge, the less force you need to apply, but the farther you have to drive it in. Think of an axe splitting wood. The axe head is a wedge. When you swing the axe, the wedge-shaped blade enters the wood and forces it apart. From knives and chisels to doorstops and even our own teeth, wedges are indispensable tools for cutting, splitting, and separating objects in various applications. Section 9. The power of compound machines. Now that we've met the 6 types of simple machines, let's explore how they can be combined to create even more powerful tools called compound machines. A compound machine is simply 2 or more simple machines working together to perform a task. Think of a bicycle. It uses wheels and axles for movement, levers for braking, and pulleys for changing gears. By combining these simple machines, the bicycle becomes a highly efficient mode of transportation. From cars and airplanes to cranes and robots, compound machines are everywhere, showcasing the incredible versatility and power of combining simple machines. By understanding how simple machines work together, we can design and build even more complex and sophisticated machines to solve challenges and improve our lives. Section 10. Simple machines in everyday life. Simple machines are everywhere. They're not just found in complex machinery, they're all around us, making our daily lives easier in countless ways. Let's take a look at some everyday examples of simple machines in action. Scissors. A pair of scissors is a combination of 2 levers joined together at a fulcrum. The blades are wedges that cut through paper or fabric. Doorknobs. A doorknob is a wheel and axle system. Turning the knob rotates the axle, which retracts the latch and allows you to open the door. Staplers. A stapler uses a lever to drive a thin, wedge-shaped staple through sheets of paper, fastening them together. Wheelbarrows. A wheelbarrow is a second-class lever, with the wheel acting as the fulcrum, the load in the tray, and the effort applied to the handles. Ramps, whether used for wheelchairs or loading trucks, are inclined planes that make it easier to move objects up or down a height. These are just a few examples of the many ways simple machines are integrated into our daily lives. By recognizing and understanding these simple machines, we can appreciate the ingenuity and practicality of these mechanical marvels. Section 11. The enduring importance of simple machines. From the earliest tools used by our ancestors to the most advanced machinery of today, simple machines have played a pivotal role in shaping human civilization. These ingenious devices have allowed us to overcome physical limitations, build incredible structures, and explore the world around us. Understanding simple machines is essential for anyone interested in science, engineering, or simply how things work. By grasping the fundamental principles of levers, pulleys, wheels and axles, inclined planes, screws and wedges, we gain a deeper appreciation for the mechanical world and the countless ways these simple machines enhance our lives. As technology continues to advance, simple machines will undoubtedly remain the building blocks of more complex and sophisticated inventions. By continuing to explore and innovate with these fundamental mechanical elements, we can unlock even greater possibilities and shape a brighter future for generations to come.